Welcome to the next in the brilliant series of videos I'm doing on redox reactions. Here's another one that you're going to need to know for stage 2 chemistry, and this is I did the permanganate one, dichromate, that's it. So we're going to be dealing with Cr2O7 minus, and that becomes Cr3 plus. Again, we're dealing with a situation where in a redox reaction you'll receive two of the chemical species and you've got to fill in the rest by following the rules. And the first one is balance the element being oxidized or reduced. You've got two chromiums here, you've only got one there, so you're going to need to double them. Great. Add water to the side deficient in oxygen. Here we've got 7, but over here there's none. How many waters do you need to provide 7 oxygens? 7 waters. 7H2O. Next step, add protons, H pluses, to the side deficient in hydrogen. Over here, none. Over here, 2 times 7 is 14. So we're going to need to add plus 14H plus. Now we're going to deal with the part where we balance the charge with electrons. Over here, you've got 2 lots of 3 plus chromium, so the overall charge is plus 6. Over here, you've got 14 lots of protons and a 2 minus. So over here the charge is plus 12. So how do you go from, it's not plus 12, 14, yeah it is, 14 and then take 2 is plus 12, yeah. So how do you go from plus 12 to plus 6? Well, you've got to add plus 6E minus. So now that reaction is satisfied. Now, dichromate is a reagent often used to oxidize an alcohol to become a aldehyde or a carboxylic acid, which is something you'll learn about a bit later. But remember that when you have a chemical species, if you're going to have something reduce at the same time, you're going to need something to oxidize, because one reaction goes with the other. Unless the electrons are able to transfer, the process cannot happen. So if I use, for example, let's double bond O. No, none of that's what I want. Drop that out. Maybe I can cut this part of the video out. Depends on how lazy I am when it comes to editing. I want to use 1, 2, 3. We'll put an alcohol group there, and we'll have hydrogen, 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 hydrogen. I'm going to go past, or you want to watch? I'm just going to watch. Alright. So this is, what is this? 1, 2, 3, methane, ethane, propane. Propane 2-ol. So we've got an alcohol and carbon number 2. You'll learn how to do all of this soon. But you can look at the formula here and you can go, well, it's got 3 carbons, C3. How many hydrogens? 1, 2, 3, 4, 5, 6, 7. H7OH. Now just because I know how this works, and one day you will too, that's going to oxidize to become C, C, C. It'll have a double bond O there, no hydrogen because each, so you're going to have hydrogen, 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 hydrogen and hydrogen. Right, so now we've got a different compound, and that's going to go via that part, and it's going to be facilitated by the dichromate. So over here we can count 3 carbons, C3, 1, 2, 3, 4, 5, 6 hydrogens, H6, and the oxygen there, which is going to be O. So now I've got the 2 chemical species that I'm going to use in this redox reaction. So we're going to go C3H7OH to C3H6O. Now we can follow the step-by-step process. When we look at this, we can go, well, shh, got to follow your nose in the playroom. We're looking at the element being oxidized or reduced. So you can see it's this carbon here which has the chemical change. It goes from the OH to a double bonded O. So that carbon is the one that's getting oxidized or reduced. And what you can tell here is that you've got 3 carbons on that side and 3 on that side. So when you do balance the element being oxidized or reduced, it's already balanced. So we can skip that step, and you can go, alright, fine. Add water to the side deficient in oxygen. If you look here, you've got 1 here and you've got 1 there. So neither side is deficient in oxygen at this point. Careful. Neither side is deficient in oxygen at this point. And then you go, right, alright, well, skip. Now we do the next step. Add protons to the side deficient in hydrogen. If you look over here, you've got 7 plus 1 is 8 protons, or hydrogens. On this side, you've got 6. So you're going to need plus 2H plus. And then you're going to go, well, okay, now we've got to balance the electrons. And you're going to look over here and you're going to go, okay, this side here is neutral. So that has a charge of 0. Over here, that's neutral, but that's 2 positives, so you're going to have 2 plus. So how do you take 2 plus to 0? Because they've got to equal, or you've got to add 2e minus. So now, we've got our 2 half equations, and they're ready to balance. Now remembering that the electrons on the left and on the right need to balance, otherwise the equations can't go together. So you've got 6 here and you've got 2 there. The easiest way to make that all balance is to times this reaction by 3. Now let's write it all out. CR2, I'm doing terribly here. Write that out. Maybe I use a hand a little more. CR2O7, 2 minus, plus 14H plus 6E minus, plus, and we're going to do it by 3C3H7OH makes 2Cr3 plus 7H2O plus 3C3H6O plus 6H plus 6E minus. Alright, now they're the 2 half equations put together. We're at a point now where we can actually do the hack and slash step. So we've got to look at this, both sides and go, well, where do we have the same chemical species? Now this is an example of an equation where there are similar. The first thing you'll always get rid of is the electrons. You get rid of 6 electrons on both sides. Now they're gone. You look here, we've got 14 protons here and 6 there. So we can get rid of those 6. We can do 14 minus 6, which is going to be 8. 8, 9, 10, 11, 12, 13, 14, yeah, good. And that's it. Everything else is not independent anymore. So we've got to rewrite the equation to represent the final one, which is going to be CR2O7, 2 minus plus 8H plus 3C3H7OH makes 2Cr3 plus 7H2O plus 3C3H6O. And that is a completed redox reaction. I'll just zoom in on the screen so you can pause the video and take your notes, and I'll also take a photo myself with cam scanner. There you go. Thanks for watching.